Hello and welcome to the channel. The vehicle I'm going to be talking about today is actually reinventing the wheel, or I should say reinventing the yaw. The established EV startups such as Lucid and Tesla seems to enter the race for the range, and each setting up a record for their respective models. The established car manufacturers, perhaps with the exception of VW, gravitate towards the expensive and exceptionally heavy SUVs with big batteries. At the same time, the new EV startups are coming to the scene and making emphasis on efficiency. One of them I find particularly unique and remarkable is a company called Aptera. Aptera's aim is to develop the world's most efficient vehicle. Let's dive a bit deeper and explore what Aptera has to offer to fulfill this type of claim. Aptera is striving to reduce the losses and achieve the highest possible efficiency in electric vehicle, hence the desire to build a light and aerodynamic car. At steady speed, there are two principal components of resistance: rolling resistance and aerodynamic resistance. Rolling resistance accounts for the impact of the friction and the resistance offered by the tire during rotation. As a good approximation, the force required to overcome rolling resistance is proportional to the weight of the vehicle and the coefficient of the rolling resistance. The greater the vehicle weight and the higher the tire rolling coefficient, the higher the resistance and more power that is required. Aerodynamic resistance accounts for the energy required to propel the vehicle through the air. Aerodynamic resistance is proportional to the square of the vehicle's speed, and power is proportional to the cube of the speed. Because of this, the aerodynamics will dominate at higher vehicle speeds, where the rolling resistance will dominate at lower speeds. Vehicle weight is the key factor for the rolling resistance, where the vehicle frontal area and its drag coefficient are the key factors for aerodynamic resistance. Taking into account these factors, Aptera focused on light and aerodynamic chassis. Aptera weighs 65% less than any other electric vehicle today. The body is built with ultra-lightweight composites, and its arched shape mimics the physics of an eggshell. To minimize rolling resistance further, Aptera have chosen profile tires and three-wheeled design that will reduce rolling resistance even further when comparing to any other four-wheel electric vehicle. Aptera body shell does resemble of an aircraft shape and achieves record drag coefficient of 0.13. If we look at the battery-to-wheels efficiency, in-wheel motors that Aptera are using will take it into another level, because in this case you will remove the losses on gearbox, on a reduction gear, etc., as well as improve the efficiency of the braking. But at the same time you are having a much higher sprung weight in the actual wheel itself, and at the same time I would like to see how reliable will it be on a longer term use, especially in countries where the roads are not perfect and you have various potholes, etc., because motor does require quite precise engineering in the motor itself and bearings. But apparently Elafa did lots of testing of this motor and it's proven to be very reliable and works well in all sorts of environments, such as cold environment as well as hot environments. If you think this is all the efficiency that Aptera engineers managed to get out of the car, you will be wrong. Aptera has another last trick up its sleeve. So it has embedded solar cells which will contribute up to 41 miles per day in ideal sunlight conditions. Obviously most of the drivers will do less than 30 miles per day. Aptera claim that this may allow some drivers to never have to plug in Aptera and never charge. I have to say that in my opinion solar panels are a bit of a gimmick on electric cars. If you take into account the efficiency of Aptera, the actual solar panels make sense. Aptera equipped with about 700 watts of solar power, which is not that much, but due to the high efficiency of 10 mile per kilowatt hour, it will give you reasonable savings, and you could save up to 4 miles per day of free driving if you have your Aptera sitting in a car park somewhere and actually charging continuously. For example, in my case I live in south of England, so it would be equivalent of zone 2, and I do drive about 30 miles per day, and in this case effectively I would need to have 2.92 charges per year, which is really incredible, and I would say in this case solar panels do make sense. Aptera efficiency brings multiple benefits. Power efficiency. It will require less power and will generate less heat. So power required at 70 miles per hour would be estimated at about 7.2 kilowatt. This is theoretical, so if we take this power and transfer it into the wheels, Aptera will get about 85% efficiency. That will be equal to about 9.2 kilowatt to propel the car at that speed. So if we divide the second largest battery pack by 9.2 kilowatt, we get that we can drive at this speed at 4.56 hours. So 4.56 hours multiplied by 70 miles per hour speed, so we'll get about 312 miles, which is really impressive. Taking into account that we only spent about 19.2 kilowatt for doing this. So if we look at charging, again, charging is limited by amount of amperage that each cell can take. So if we estimate that value, it would be about 126 amps. So multiplied by 403 volts would be about 50.8 kilowatt. Again, this is not very high value, but if we take into account that Aptera efficiency is about 10 miles per kilowatt hour, the charging speed we will get at this rate will get about 500 miles per hour, which is absolutely tremendous. Then if we look at the performance, so the estimated pack configuration of Aptera is 96S26P, so 96 cells in serial and 26 in parallel. So basically we will get that continuous discharge current is about 9.7 amp for this type of cell, while maximum discharge current is about 14.45 amps. So if we take this calculation, so we can get continuous power of 82 kilowatt and maximum power of 131 kilowatt, which is not huge, but taking into account the Aptera aerodynamics and weight, so that will give us a similar performance comparable to Tesla Model Y long range, which will require a much bigger pack for this 96S46P, which is equivalent of 300 plus kilowatt peak power. Thank you very much for watching. I hope you enjoyed this video. If you are interested in EV technology, please have a look at the video over there, or perhaps this one over there, and I will see you on the next one.